All right. Hello, everyone. My name is Ahmed Abdul Wakil, and I will be your host today for IPIP chat number 2. I hope all of you are safe at home and doing good amid level 5 lockdown here in Ireland. Before we kick off our today's event, I would like to share some background and main motives of IPIP group. Uh, IPIP has got 4 focus areas. The first one and the core part is the knowledge sharing. The second one is the building the bridges among the local community. Third one is open access platform. The last one is entrepreneurship. In this way, IPIP enables the IT professionals to serve the community by contributing to and organizing the training and guidance seminars for students who aspire to make a successful career in the fascinating area of information and communication technologies. So, so what do we mean by the knowledge sharing? By knowledge sharing, we mean that through its websites, a Facebook page, and live fire chat sessions, IPIP group will enable ICT professionals to share their knowledge and keep providing information about emerging trends and upskilling opportunities and job openings. And the companies which are set up by Irish Pakistani IT professionals will hugely benefit from this knowledge base and will be able to use this platform to search for talent, freelance, the developers, and outsourcing opportunities. In the scope of entrepreneurship, IPIP enables like minded ICT professionals to share and discuss their innovative ideas, identify individuals who share similar passion, and form groups that should lead to startup ideas and setting up new companies. Yes, that should lead to startup ideas and setting up new companies. IPIP will be engaging with incubation centers, startup hubs, and sporting organizations to enable the IPIP members to benefit from these links. The third focus area, as I said, is building the bridges. Along with all above, IPIP will enable Irish Pakistani IT professionals to build the bridges between Pakistan and Ireland, by effectively engaging with organizations both in the public and private sector that will promote the development of the IT sector. IPIP is, like in the future, has plans to hosting initiatives that promote the professional, cultural, and intellectual exchanges. It is envisaged that IP members will lead several IT projects, will form these subgroups to make continuing progress in achieving these goals and objectives. The last point is very important. That is the open access platform. Open access platform. We believe that IPIP is different from many other initiatives of this kind. IPIP is an open access platform for Irish Pakistani IT professionals. If you are an Irish Pakistani IT professional and wish to support this idea, we request you to please get in touch with us and do join in. Share your ideas with us, help us to refine these ideas, and join us to practically deliver these aims and objectives. Next, okay, so the website address is the www.ipip.ie. Now, before I kick off the session and start the introduction of the panelists, I would like to spend 2 minutes to say some words about our dear late friend, Dr. Farooq Mirza, who was a vibrant IPIP community member. He had contributed in our first IPIP seminar and was the front runner of making it, of making it a successful event. He's not with us in this world now, but his contributions done in the past will definitely help the local community in general and IT local community in particular. Now let me share a video here in memory of our late friend, Dr. Farooq, which is compiled by Nawaz.
First of all, I would like to introduce Dr. Farooq Mirza. Dr. Farooq Mirza is a head of API development in the Bank of Ireland. He has 15 plus years experience in international industry across a variety of industries in multiple technical, management and leadership roles. Farooq has PhD from
So personally, if I haven't moved a role in more than 2 years, I would think that I have reached glass ceiling, and this is a tough spot to be in. And the first time somebody needs to, the first thing someone needs to realize, if they are thinking that they have reached a glass ceiling, there's no more movement, there's no more progress, they need to realize there is something missing. Something needs to change. Einstein's definition of insanity is doing the same thing over and over again and expecting different results. If you want different results, you need to change something. So the first thing that I have done a couple of times before, and I would also advise people to do, is to set a target. What is your next step? Then try to understand what is it that is expected in that next step. The third thing you will do is try to find what is it that you are offering and what is the difference between the next step and what you are offering. And then the fourth step, once you've realized what is the difference, what is missing, then you go and learn those tactics. You practice them. You talk to your friends, to your peers. And then once you are there, then you are ready to take that next step. And one of the important things somebody told me, or somewhere I read, was that once you have achieved a goal, from 2-3 months onwards, start setting your next goal and start preparing for your next. It will take at least 1 year, maybe 2 years to actually break that glass ceiling. If you're lucky, you can do short. If you're much smarter than I am, you'll do it in a much shorter period. But generally, it will take 1 or 2 years at least to shift from your current mindset. And you need to focus. The focus is absolutely critical, very important. You need to focus on your target. What is your goal? What is your next? The word I'm here using is next step. It's not your end goal. The end goal is you'll grow up hopefully to be 80 or whatever and retire in a nice villa somewhere. That's the goal, that's the dream. But there are steps to reach there. So always aim high. It's better to aim high and not make it than to aim low and make it.
All right, guys, let's make it the reality. Next, I go to introduce our panelists before we kick off the discussion. First is Dr. Muhammad Atif. Atif has got 15 years of programming experience and over several years of expertise in academia industry linkage in the space of machine learning and data analytics. Atif has contributed to several IT projects funded by Enterprise Ireland, Science Foundation, Ireland, and EU. Our second panelist is Nawaz Zay. He has got 18 years of experience in the software industry. He has worked in health and finance domains and currently working as tech lead and architect. Our third panelist is Dr. Akil, who has got 10 plus years of experience in the area of the ubiquitous computing and data science. Akhil has contributed in multiple Internet of Things, IoT, and smart city projects which are funded by European Commission. And recently, he has been working with the Transport Infrastructure Island for paving paths towards smart tolling. Our fourth, our fourth panelist is the Zishan Khan. Zishan has got over 20 years of experience in software industry and work in startups, SMEs, and large organizations. Zishan has worked as a CTO and currently working as a head of engineering in company focusing on data analytics and the predictive modeling. Then we have got Mustafa. Mustafa has got 15 plus years of experience in IT industry, worked in telecom and healthcare service sector. Mustafa's area of expertise are in data and business analyst. We have got Tokir. Tokir has got 15 plus years of quality assurance, Q&A, and test automation experience. He has worked on various projects, both in private and government sectors in the past. I would like to say special thanks to Ikram Niazi, who is the core committee member of IPIP. He's not in the screen, but he is now helping us in the background and will be taking care of all the questions on the Facebook. He will try to answer them in line, as well as he will be passing on to me, like your questions that we will be answering at the end of the session. To be honest, we're lucky to have such people in our local community with loads of IT experience in diverse areas. On top of it, they look forward to give back to the local community. I would like to say thanks to all the panelists who have, taken out their personal time, to do the preparation and come here and try to help us back in the community. So our first area where I would like to ask our panelists to start before I go into the depth of the session and the top training opportunities in the IT industry. We have to ask ourselves the basics, because many students, many people who are entering into the graduation or post graduation, they always ask and they have many questions. And before we give them the in-depth knowledge of any field, they say why IT, so why you guys have chosen IT. Can I ask Dr. Atif, like in your personal experience, that why you chose IT in your career?
Thank you very much. So I think like the more important question nowadays is why should anybody choose IT? I mean, the reasons why I chose it was many years ago. And I would say, I was fascinated with everything that you could do through programming, and you don't need a lot of budget, that you can express yourself, your ideas, and take them out there in the world. That was one of the reasons why I chose initially to program. If you compare it, like you require a lot of heavy investments if you want to do some experiments regarding engineering aspects, solar energy or something like that. But if you have in front of you a computer, which nowadays everybody has, so you could experiment right then and there and see what are the results. Or if you want to imagine something, you can bring it to life in a way through computer. So that was kind of the zeal behind that. But if you see the trend and now what's happening, and even back then as well, but it has just strengthened over the period of years. The thing is, IT or computer science, in to be specific, is kind of the core of almost all the sciences these days. It's kind of, it has taken the role that maths used to have around every other subject, where if you want to give science a language, perhaps that language is maths, and the grammar of that would be statistics, right? So now what is happening, if you are in medical, if you are in astronomy, if you want to fly to Mars, if you want to do some experimentation around green energies or anything to do, or even if you are building bridges or even nuclear plants, everything and everywhere you need IT nowadays. So whether some sensor would fail, you have to predict before it fails, or whether you want to do automation around like automatic cars or something like that, even drones. Computer and IT is at the center of that. So the way I will phrase it, IT or computer science itself is not a discipline in itself, because it is so multidisciplinary that it goes into every other discipline. So if you see that what's the significance here is 90+% of the applications that we see in the market these days are in outside of original computer science areas. So when I say outside of computer science areas, I mean to say the traditional computer science areas would be developing an operating system. That's very rare, right? But a lot of the people would be out there solving problems for fashion, problems for finding new drug, solving problems for, reaching out to remote destination through networks and failures and all these kind of things. But the application is actually around reaching out to people in different ways and solving their real world problems. So that is where I say, IT is at the center stage. And if you are in IT, you are plug into every other field, and you just need to choose and you can go into that application. So I think that is why IT is very interesting. And some of the reasons why I chose IT was there, but of course not that well crafted. Like if I were to choose IT again now, these would be some of the reasons that I would choose it again. I hope that answers.
Yeah, sure. Thanks so much, Atif, for a detailed insight. Like as we will make a progress in the session, we're gonna ask, we will have more opinions around the same area. On the same area of why IT, can I go to Dr. Akil, and can I ask specifically, why do you think IT is one of the best field in the future as compared to other fields like mechanical and electrical engineering? Dr. Akil.
Thank you for taking me on. As Dr. Atif mentioned, I think he rightly said so. I think it's the market factor that makes IT such an important subject that offers many career opportunities as compared to, let's say, other science subjects. As Atif said, IT almost touches every aspect of today's life, whether it's the products that we use, such as computers, smartphones, tablets, or the services that we use to interact with the rest of the world. Even if you don't work in IT, you're working in a company or you own a business, you will still have IT operations and services. And at present, IT services and softwares, they make up a large portion of our economy around the world. IT companies have grown significantly in the past few years, and that's one of the reasons why there's a high demand for IT professionals with great salaries. So I take it more like why you should go into IT field. It's the market factor as well, and that's one of the reasons that drives people choosing a particular career. Now, technology is part of our present and future. So if you want to develop tomorrow's products, you should choose IT, because IT is infiltrating in every other discipline, whether it's science or social science, whether these are citizen-centric services in this modern cities today, or whether these are services to elderly people to make them live independently in their own houses and monitor them remotely from a location. So this is not a kind of career that you only choose just for money, just to clarify on the point that I made earlier. You'll need a lot of passion and determination to go through the fundamentals and take in all the theory and concepts. So as Atif mentioned, that you should have an interest in this if you want to learn new technology, or if you want to learn new frameworks and tools every now and then. I think IT is the career that you need to choose, and IT is the subject that you should study.
Thanks so much, Dr. Akil. Really appreciate for a detailed input. Now, let me go to our next, area, and that is the hot technical trends to land an IT job, which is one of the core aspects that we want to cover today. And in this scope, I'm gonna go first to Nawaz, and then I'll go to the rest of the panelists as well. I hope all of you must agree with me that there are too many new buzzwords in the IT market, right? And people who are new in the market, are all confused. I have talked to the people who are in the first year of the IT, or they're almost in the final year of the studies. When they go to look into the job profile, or other things like online seminar, so they have told me that there's so many buzzwords going on, and at times it's not easy to differentiate between them. So can I ask, Nawaz, that what are the technologies being used these days in the IT industry, and hence their correlation with the job titles, Nawaz? You're mute, Nawaz.
Thank you very much, Ahmed. The title is very interesting when we read any job description, or we read anywhere is a requirement. We are going to meet some manager, or we are going to meet another friend. So it's all been used as a title. So for me, the title is a term which describes the person, what he do. So the title could be like when you are going to see a word as a manager, as a director. It could be is a VP. It could be something a senior person. So as you see the first buzzword, you immediately understand the role and job he is going to do that one. So this is the managerial type of the roles. But if you see someone, he is going to say, I'm a tech lead, I'm a principal engineer, or I'm a senior software engineer. So now you understand that person, what type of the responsibilities he is going to do or he is doing as is today. When you see another type of the titles, someone is going to say, I'm assistant, I'm associate, I am an intern, then you understand immediately what type of the responsibilities he is doing that. So when you see in a very organizational structure, the organizations are actually give a full career path, and they always start from something intern, then they go to associate level, then they go to say a software engineer, then they go to senior, principal software engineer, or director or tech lead. So the title is very important when you go any job portal and you see immediately what actually the employer is looking for. If you little bit go in depth, and you will understand this is a one or two words which is going to actually explain the job role and describe what employer is going to asking for that. Similarly, if you go to any like someone is a technician, so you immediately understand what type of the technician, or if someone is going to say, I am working as a network engineer, or I'm working in technical support. So the most important for us when we are going to write down our CV, or we are going to describe ourselves, so we just need to use these buzzwords. What currently it is currently in the market. Match those things with your LinkedIn profile, and make sure those titles what you are using, they actually have been assigned to you by your previous employers. In case if they are going to go back for reference check or anything like that. So IT industry is emerging a lot. There are loads of new titles. Automation engineer, it used to be not there. We have a DevOps engineers, it's brand new. Data scientist, AI engineer, or you just go in IT sector and you see that there's a loads of, we used to have a system analyst, a data analyst. Now these guys, they are saying we are looking for a Scrum Master, and that Scrum Master must have a system analyst, some sort of the high level understanding. So for me, the title is the main area where everyone needs to concentrate when they are going to apply, and when they are going to understand the second person, what type of the responsibility he is going to do that. I hope I was able to grab high level job titles is what we are dealing with those ones.
Excellent, Nawaz. Thanks so much. Can I ask, Zishan, on this area, if you want to shed some light, Zishan? Like I know that you have worked in many companies in different roles.
Yeah, thanks, Ahmed, for so I will try to answer this question with some examples with the real job titles and the terminologies used, even though Nawaz had explained it brilliantly. So some of the titles that you may see when you enter into your career could be like backend developers, So they may be working in the, you may see the terminologies in the job adverts like Python, the Django framework, which is used for API, or Swagger. You may also see for the backend development, the low-level scripting, Perl, Bash scripting. So if you're choosing a career where you like more like these technologies, then the backend developers are title is good for you. DevOps had been explained by Nawaz. So that's mostly, those guys are mostly working in deployments, automation of deliveries, for example. These days, Ansible scripts are quite hot these days to deploy the software and to perform the rollback, or to provision the servers and services at the click of a button. Similarly, front-end developers, they use Angular, React, these days HTML5, Node.js, JavaScript, CSS, hands-on table, and you name it. One of the very interesting titles these days that you may see, primarily in the larger organizations like Amazon or Google, is the site reliability engineer. So SRE are primarily responsible to look after the core infrastructure, and it's more applicable towards the production environment. Whereas DevOps, on the other hand, is a practice used to automate and simplify the dev team and their non-product production during. And then we will also cover this data science engineer and data analyst. So these are the experts who can solve complex problems using patterns found in big data. Nawaz also talked about infrastructure. I think you did talk about infrastructure. Oh no, sorry, you talked about the automation expert. So it is a cross between infrastructure and the DevOps role, where infrastructure engineer is more looking after the infrastructure, cloud administration, backup of databases, for instance, performing patch upgrade, instance provisioning, and basically the general system guidelines. Yeah.
Perfect. Thanks so much, Ishan. Now, as this section is about the hot, like the hot technical trends to land an IT job, and we already have covered, that why to choose IT. We have gone through different, terminologies and different, job titles. Now I would like to do a bit of, deep dive into different areas that about, what are the hot trending, like tech stacks. So what are the hot trending like tech stacks that newcomers must to have or nice to have? What about area of the service development, like a standard, like in terms of software engineering or development? Maybe I'll go back to Nawaz, and if you want to shed some light on the software development area, tech stack.
Yeah, thank you very much. This is, again, is a software development is changing. The tech stacks, the technologies, the ideas, the business requirements are changing with the blink of eyes. The technologies also are evolving. If I remember correctly, I used to have a Fortran C language, and they were winning. And then immediately Java came, and in Java is still alive from the last 22 years. But still, there are loads of other tech stacks. They are saying, no, you can do better in a different set of technologies to deliver the similar type of the job. So for any person who is working within IT sector, he has to be very careful what he is going to learn or what he is going to make himself a proficient in a couple of technologies, so where he can secure his job for the next, say, 2 to 3 years. The similar thing for the businesses, when they're going to develop or ask a develop a product, they need to choose, or they need to ask what are the best tech stacks are you guys are going to use, which are going to be very helpful in relation to the cost and maintenance. Like we still have a loads of products in the market where they are expired or decommissioned, but businesses, since they have paid a loads of money on a last day, which is already on deprecated product or deprecated language, so they are paying a loads of money just to maintain that code base. So what I understand, there are a couple of tech stacks. The first one is a mean uh, tech stacks. This is a very famous. In that tech stacks, what we are saying is MongoDB. You are going to have Express.js. You are going to have Angular and Node.js. And this is from the last maybe a 2 to 3 years. This is going at the top of the stack. So every third person, every third company, which they are building any application. So when I'm saying any application, every application requires a minimum client, a minimum a servers. So client and server, where you are going to retrieve data from the database, you are going to display in any format. It could be like a web based, it could be like a mobile application, it could be your reporting tool. But you always play with client and server terminologies. So the mean stack is going to be a winner, and it is winner this year. And I was reading somewhere in the internet, and they are saying in next 2 years, this stack is going to be everywhere. We have another tech stack, which is a Merlin. So in that tech stack, they just replace with Angular to React. So you have a MongoDB, you have a React, you have a Express database, and you have a Node.js. Then you go back a little bit, and there's another tech stack is picking up a very fast, which is a serverless. So everything is going to be serverless. Sorry. So what serverless means is you don't care about who is going to 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 entertain or going to give you the data. The best example I can give you is AWS Lambda. They are the first one in the market. They took the full responsibility of the service tier, and they say that, okay, we will build. You don't have to worry about building the mid tier, building the integration between the database and the server. Just write on a small lambda function. I will give you the data, and you simply render that data wherever the way you want. It's going to be interoperable. So you don't worry about the your OS. You are going to be in Windows. You are going to be .NET. You are going to be Java. No, the language layer, they have removed it. They removed the operating system layer. So this is also is very much picking up. But if I will say as a developer, what you guys need to do that one. So there are loads of tech stacks. One is I would advise you must learn at least the Angular or MongoDB or Node.js if you really want to secure your job as a software engineer or as a programmer, because the most jobs will be in that tech stacks. The second one, if you go back to the hottest or the most demanding languages are in the market. So if you see that, you will see a JavaScript is picking up very fast. You will see Python is the top one. So go and learn Python. Python is something which from the researcher, from the analyst, from any network engineer, any security guy, everyone has to write on some script. And that scripting language is very powerful, and it is in high demand. If someone knows Python, he has a better chances to secure a job. So I will go for Python, I will go for a JavaScript or TypeScript. And the third one, which is still very famous, is a Java. So if we talk about Java, everything as is today, 85% of our all the hardware is running with the JVMs. 95% of financial sector world is relying on the Java developed applications. So Java has a Spring, it has a Hibernate, it has a Tomcat, which is another container. It has a Dockers, it has your Jenkins and all those configurations. So when you're going to choose a tech stack, either you're a very senior developer or you're just going to land on that one. Always keep an eye what is in high demand this year or what's going to be in high demand next year. What are the most job opportunities in which area? So I should land on that one. So obviously, when I'm talking about MongoDB, I'm talking about a NoSQL. I'm talking about you are going to be like a non-relation database. You are going to have a millions of records, and then you can do any type of the analysis on this one. So being a programmer, you have to concentrate on a set of technologies, a set of languages. On the top, just keep an eye what third party are going to advise you. So that's all I can say on this one.
All right, thanks for my Nawaz. Yeah, like very detailed insight about the top, tech stacks, and like horizontally covering, different areas on the client side and front side. I hope this is gonna be helpful for the newcomers and people who are in the first few years of their career in the development sector as well. Uh, Now we have covered horizontal aspects of general, software development. Now let me go, a bit to a vertical sides. We have different areas, and I'll now go to Dr. Atif to ask if you can cover a bit on the you see, like on the area for data capture side in the software development. That what kind of data types are there, that exist, and how you deal with of developing a solution about data capture and data types.
Sure. Okay, so I'll give an example while I respond to it. So it's really essential for every project, no matter at what level you are doing. If you're commit to a very quick iterative process, maybe a 6 months project or a year project, or even if it's a product which stays for long, like product like Facebook, or that stays over there. The important bit over there is always the data capture. So what's the data set on which you are going to define your processes, from which you will infer some information, and then that transform information will be your product, for instance. So let's say if I want to analyze what's happening in politics and I am running for an election campaign, for instance, like this is what is happening in US and has happened before as well. So I might want to hire engineers, or perhaps you can call them these days like data scrappers, or the people who can capture the data. They're experts in data crawling, streaming data, or different types of data are over there. When we talk about streaming data, that means the data which is continuously coming to the pipeline, such as like live stream of video that is happening right now when we are talking to each other. That's a streaming data. And there could be a data that comes into the pipeline and then it disappears, and then we see it maybe after a day or two. Those kind of data could be, when somebody publishes an article and then you want to generate a report on that article, perhaps after a day or a week, that is not definitely a streaming data type. So what happened is, like when you have a project, like I gave you an example earlier about the political project where I'm running a collection campaign, I want to know about my voters, right? And if I want to know who can vote for me, the best way to look for the data is social media these days. So as a data capture engineer, or as a person who can crawl the data or scrap the data, you are expected, first of all, to know API specifications of different social media platforms, and then develop strategy using within the legal limits, and crawl the data from Twitter feed. So for example, if there are privacy issues, you should not violate that. And if Twitter says you can only access to certain kind of things in a certain way, you should not violate that. Otherwise, the data that you are gathering from them becomes illegal, or perhaps they will choke you and you can't collect the data anymore. So as a data capture person, you're supposed to understand the data ethics. You're supposed to understand the specifications of the API. For instance, for Twitter, the API can change every then and now because it's dependent on company. Then if you are crawling the data from Facebook, again, the specification is defined by the Facebook. And if they revise their specifications, then you have to change those specifications. Likewise for YouTube. And for instance, if I'm looking for, let's suppose, who publishes hate content coming from, if I'm learning a project which is good for digital literacy and citizen journalism and all these kind of social good projects, which a lot of the public funded projects are about in the space of social analytics these days, is about identifying who is spreading fake news, who's spreading biased news or hateful speeches and all these kind of things. That might come from social media. That might come from even published article websites, right? So there could be some kind of journalistic websites which are not ethical, but when they discuss a certain idea, they might have certain hate connotations around it or skewed connotations around it, or they might have morphed information. For example, showing you a fake image, an image that took place somewhere, let's say, in 1950s, and show what 2020 immigrants are migrating to Europe, for instance, whereas that image could be long ago Europeans at some point in the World War II migrating elsewhere. So those are the cases that we know. But as a data capture engineer, you're supposed to gather the evidence from wherever, whatever is required for your project's end result. So if, for example, if you talk about COVID scenario, and there are projects around COVID, let's suppose, what are the research publications that are recently published? If you are going to have a product around that and say, this is the new drug which we have discovered, or this is the new drug under the discovery, or this is the new practice, or this is the new sign, or this is the new viral symptoms that we have seen. For that, definitely you need to have an API as a data capture engineer to have an understanding and specification of understand the specification and legality and licensing around that, so that you can crawl the research publications, whatever is within the legal means. Of course, as a data capture engineer, you're not supposed to process that. That's for someone else to do. But your target is to have those API, understanding of those API, and then bringing the right data so that it could be processed by someone else in your team. Likewise, there are sensor data. For example, IoT is here. People are jogging around. How well are they doing? What's wrong with them? Or aged people, maybe they might fall before they fall. You want to predict that, but the sensor is capturing certain heart rates and certain information, and then you need to write certain APIs around that gathers those information. Or perhaps maybe you will be a participant when you're designing a new hardware, talking to hardware engineers, and having your own specification around that hardware to capture the data. So data capturing is all about understanding the API specifications of the data provider, and then aligning yourself with that and ethically collect the data and make the data as noise free as possible, cleaned up, and pass it on to the next member of the team, who then would process that. Of course, there would be somebody from the storage side as well, which I think could be another question. So here I'll stop my answer.
Thanks so much. I believe you have covered, very important aspects of data capturing on the streaming side, on the use cases as well. And now, if I just expand on the same thing, that once a data is captured, in terms of a batch data or a streaming data, and the data is in rest, can I go to Mustafa, who is a database analyst and is expert of databases. If you can shed some light that based on the use cases, what kind of databases are available and when you will be using, what are the trends of the databases at the moment in the market?
Thank you. Just we are talking about the text and stacks. So in the text stacks, the databases are a very important part of it. So in database, we have to decide which we need to use, like is it a traditional database or the non-traditional database, like the relational database or non-relational database. It's all depend on what your product is or where you want to use it. As now, if you see, because the mobile apps, the social media and IoT apps, so this will change the whole structure of the databases. The NoSQL database, which is now a very important part of it, because there's so much big data, so we need to store the large amount of data in very quick way and then retrieve in the real time. So then in that case, the NoSQL databases are very popular nowadays. So then the non-SQL, some of them are like the MongoDB, or if you see the AWS providing these sort of databases. But in part of these ones, so we have to also emphasize on the relational database, which is still a very integral part of in all the applications. The traditional database, which normally is using from the ages like the MySQL, SQL database, Microsoft SQL, and the Teradata. So we have to emphasize on both of it. So we have to just create a balance in developing a new skills, like we have to use the traditional database or non-traditional database. So the main thing is to go and learn, get the basics of relational database, and then on the top of it go to the non-traditional, which is the NoSQL databases. That will help you a lot in finding a new jobs and getting a new trends in it. So we can't say we have to choose both, but we have to choose the both as well to get involved, like in stay in the market and understand what's happening in the world. So I hope that will cover the most of the databases stuff.
Very nice, Mustafa. Thanks so much. Now, like I'm gonna expand more like on this, and can I go to now to like Zishan, and because you have got experience as the head of engineering in in the data modeling side, so we have covered aspect of development and the databases and the data capturing. So, but if you want to apply the machine learning, so what are the top trends of the tech stacks in the scope of the big data and machine learning there?
Right. Thanks, Ahmed. So basically, we Mustafa talked about big data. So let me just quickly sum up what big data is and what is the association of big data with the predictive modeling and AI and ML. So big data is a science which involves gathering and analyzing the large data sets that are otherwise too complex to deal with using traditional data processing application software. So big data is also closely associated with predictive modeling. So the predictive modeling uses the data sets to predict the outcome of anything. You may have heard the phrase that data is a new oil. So those companies who can harness the true value out of the data can gain competitive advantage over other companies. So the data can allow the generation of new insights and visualization of data into creating value. Often the big data is stored in data lakes that can take structured and unstructured data. Then a search engine coupled with the ranking engine can find the right data to do the analysis. Based on this, predictive modeling is performed. So I'll give you like 2 or 3 examples about the predictive modeling, how this is performed. So first example is, you must have had heard about weather predictions, like prediction of rain, wind, snow, storm. So the weather station uses predictive modeling to report such predictions. So first step is to gather the data from multiple sources. Second step is to clean and structure the data, and there are algorithms to do that. Then to load the data into the predictive modeling engine that analyzes all of those patterns and then predict the outcome. Second example I can give is could be the forecast of the stock performance. So many hedge fund managers do use systems which has predictive models to predict the future growth of the stocks. The third example I can provide is from our daily life. So the another form of predictive modeling is to calculate the aggregate exposure of a certain chemical that may be found in pesticides, your house cleaning products, your perfumes, your shampoos, fragrance, and for instance, a toothpaste. So the data from surveys of countries are collected and loaded into the database and into the model. The model then evaluates the pattern based on the daily, weekly, monthly, and yearly usage of those products, and then calculate the aggregate exposure on human body. For instance, it can then predict that if a consumer keep consuming those products, for example, 10 years, then they may have a higher chance of cancer, getting the cancer, for instance. And based on such models, for example, the food safety authorities around the world can force the companies to reduce the overall chemical composition in a range of products. I hope that I answered that what you were asking, Ahmed.
Yeah, definitely. I think that, like as you said, like the data is the new oil. Like I really, like that statement. And I hope the way you guys have explained, all the way from the tech stack to the data capturing and streaming and batch data, then to the databases, then the data insights. I hope this will give a bit of motivation to the newcomers into the IT industry as well, and they will also understand that when we talk about a software development or a big data, like it's not just about the analysis. It's not just about dealing with the data. There are many aspects like horizontally, where we will have different job roles, and people like are working with the overlap aspect, but still there's a distinction of different areas of like in the IT like industry. With this, so far we have covered the development aspect, and we can't skip the area of automation tools, right? And because in any stack, in any aspect of use cases of the whole pipeline of the database as well, there's always a notion of the automation, and to give the confidence and to make sure that anything we are updating goes up to like up to the customer with the confidence. Can I ask now Toki to please jump in and tell us that what are the top uh, like trending tools in the automation tool like automation testing side, Toki?
Thanks very much, Emmett. So just give you a bit of overview of the background of what automation is, like, for the audience. So we as QA or automation engineers basically sit right at the end of the pipeline where what you guys have talked about. So we sit between, we work along with the developers and the release managers or the release side. So we kind of sit like, between development and before the product is going to the end users or the people who are going to use it. So my job or QA engineer's job is basically find issues, anything that is being developed, and it's something that is going to be basically verifying that it's basically according to the requirements of the people who are going to use it. And when we say QA, it's basically quality assurance. So what it means is like, we basically assure that the product is according to the standard and according to the requirements of what is being asked for. So we work along with the developers, finding issues and on a constant basis, like, different functionalities that is being asked by the user. So it's not at the end of it, like, it's not quality checking, it's quality assurance. That's why it's quality assurance, because if you work alongside with the developers. So that's very important to know. And it's not been very highlighted among, I think, like, I've seen very, very rare people from Pakistan origin, like, who've been in this area. So it's kind of not as much known. So that's why I wanted to give an overview on that. So we talked about like databases, we talked about APIs, and we talked about like, some of the front end. There are multiple layers again in the automation. So there are automation engineers who basically work on a DB level, on a mid-tier level, and the user interface, like the UI level as well. Like, so we work at all these different full stack level. The tools that we generally use, like, or maybe are in the market at the moment, like, are basically, again, it kind of double to check, like, what Nawaz and Zishan and, most of the people have said, like, so we basically use at the moment, which is highly required at the moment, is basically Java or Python. You need to have like, beginner to intermediate level expertise on those languages. For testing, like, we kind of use Selenium, we use JMeter for performance testing, and scripting again, like, it could be like, Java scripting, which is currently I'm working on as well, is highly in regard. Some of the PowerShell scripting that could be used as well. Good idea to know about the robot framework, like, which go along with the Python. So that's something that would be very nice to have. And for behavioral development driven development, like BDD, is very, very good, like, to know if you are into the automation area. So BDD is basically you can look at some of the Cucumber framework or SpecFlow or things like that. So these are the main tools, like, they're kind of like duplicating of what the other guys have said, but as we work along with the guys, those are the main ones that to be used. Just one thing to say, like, so automation is not the only thing that we do, like, or it's just if you know about programming, it's not the one that will land you in the job. So you need to have some sort of an acumen for breaking things and finding issues. That's the core of it. That's the gist of it. Like, our code, what we write is basically test the code of the developer. So we basically write code to check the code, and the idea behind is like to break it, to find issues, like, that before the user find it. So that's the important part of it. So seeing things from the end user perspective, finding issues, finding where could be the problem, and they're all the issues, like, so that's where we come in, and we're like, before it goes to the end user, we have to find, like, that things are up to the scratch. If that makes sense.
Thanks so much, Tokir. Can I ask, like, that's a 20-second like answer, from Mustafa, and Zishan and Tokir, that from the big big data analyst side, or the data modeling side, or the quality assurance side, right? So how easy like it is, like if somebody has got experience in the automation, like in development, but he want to now focus on the like on the data analyst, or you want to go to the like to the modeling side. There is a big learning curve. It's a bit easy. How do you think? Just like a short answers, guys. We will start with Zishan.
Right. So basically, if you are moving towards the data engineering, for instance, and you already have covered the experience, you have already accumulated the experience from, let's say, from the software engineering, then you will find that you may have to learn some of the processes that are possibly non-traditional for the typical software development. For instance, you may have to learn about the ETL processes, so which is the extraction of the data, transformation of the data, and loading of the data into the database. And then you may have to learn the concepts about the data lakes, because when we talk about for example, data science and engineering field, it is a bit different from the traditional software development, because you have to deal with a large quantity of data. And not only large quantity of data, you need to see that the data must be coming from multiple sources. For example, it may be coming from a PDF file. Some of the companies specializes in making tools that are expert in, for example, image recognition, so that they can read the scanned copy of the data for those companies who are still having a large physical format of the data. So they need to be adept in such sort of tools. They need to come up with the innovative ways to not only to read the data, but also they need to take into consideration about the performance, because if you are gathering a lot of data,
Can I stop you here? So see, like, based on the time, I have to go to the other other like panelists as well. So my question is, like, can I ask Mustafa, that if a person has got experience of a software development or a modeling kind of thing, but now he want to go towards more kind of data analyst side, is it like easy, or he will need like a long curve to like reach there?
Thank you. If someone like is in software development, so he want to move to some sort of data analyst or data science, so in the learning curve side is, I say, because if the basics of the IT is clear, or all the terminologies, so it's not a big curve. But the main thing which is already Zishan covered is like in the new world nowadays, the data is more coming from different sources, and now most of the time the data is part as a real-time data. So you need to learn the tools which handles the large data, efficient way to learn to load the data or move into it. So now in the traditional and the new world, the main part of it, which is the big data and the real-time data analysis. So the learning curve side is just need to learn some few new tools which use these things, but the concepts or everything are the same what we are learning from the day one when this IT starts.
Very nice. I think so. This is a motivation, for many people, because like I meet many people. I got a feedback, from you guys as well, like offline, that many people who feel that they're stuck in one area, they feel a bit of difficulty to move to the other. So don't be afraid, guys. There is a big overlap of different like aspects. So with this, I'll go to the the next section, which is specifically we're going to dedicate a bit of time to see the different career paths in the IT industry. So before I jump into the question, I just want to ask all the audience who are listening to us, like in a live streaming, if you have any questions, this is the opportunity. And see, like all the panelists have got a like diverse experience. They are looking forward to answer your question now live, or even if they were even if we don't have answer, we will be more than happy to take the answers offline and do a do a connection with you and try to help you as much as we can. With this one, can I go to the next question, which I received a pre-event from somebody, is that and I'm gonna ask start with Dr. Akil, that so guys are a bit confused that they're saying we are receiving many job specs with overlapping required skills. So what are the most trending roles in the IT market, and how we could sell ourselves with so many overlapping specs but different roles being advertised in the job portals? Like Dr. Akil, if you want to shed some light on this.
Okay, thank you. So since we are talking about data and data science and hot trending topics, so there are so many roles that are advertised when you see online when you apply for a job. I actually categorize them into three main types. So you can see those titles that fall into the category of data processing, then data analysis, and then there are some business related roles which are less technical. So when it comes to data processing roles, on the top you would see data architect. That's one of the titles that most of the job offerings will use if they require a data architect. A data architect conceptualizes and designs the data frameworks for a business, for instance, requiring, as mentioned by other panelists, for instance, if there's a business that requires integration and pipelining data coming from heterogeneous set of sources, then there's a similar role, but it's a lower level role. It's data engineering. Data engineer actually engineers build and maintain frameworks that are conceptualized by architects, and they mainly use them to process large data sets. So like any asset in a business, data has a life cycle, and during its life, data may go through a number of stages. It may be extracted, exported, imported, migrated, validated, updated, transformed. These are some of the terminologies that the panelists have already used. By doing all that, a data engineer just prepares the data for someone else to analyze it. Then on the other side, we have roles such as data analysts, data scientists, business analysts, or business intelligence related topics and role titles. So data analyst looks at the data which is prepared or processed. Most of the time it's semi-processed or completely fully processed, and seeks to identify trends with the help of statistical techniques. Mostly the techniques used by data analysts are statistical. They may also create visual representations. They may use graphs, charts, and some visual tools to showcase what the data reveals. Then we have a role which is very popular, data scientist. Most of the people, they hear about it. And when we look for a job, like we see this title up being used by many companies offering this job. So data scientist actually is a role that requires data engineering, some knowledge of data engineering, then some knowledge of statistics, and now these days a bit of knowledge of machine learning techniques. In most of the scenarios, data analysts and data scientists, they need to combine technical know-how with the business knowledge to acquire insights while acquiring insights from the data and then converting those insights into actionable information for the business of the company. So
yeah, sure.
did I answer your question?
I appreciate it is a detailed answer. I hope the audience is getting help on this one. Now, guys, I just have got a question, like on my WhatsApp, and like a guy is asking, and he's listening to our audience, and so he's listening now to the live stream. So that he asked a question, and I'm not very good at maths, but can I become a data scientist? As so the question is, I'm not very good at maths, but can I become a data scientist? Can I ask Akil and Atif to share like a bit of insight on your opinion on this?
Okay. Atif, would you like to go first, or maybe I can say a few words and then you can.
Okay, thank you.
Okay.
So go on, please.
So data science indeed has a huge role of mathematics and statistics in it. Most of the techniques that we use in data science have their foundations in calculus, linear algebra, and statistics. So if you're terrified of math, or you're unwilling to ever look at mathematical equations and solve them, you're not going to enjoy much doing data science. You're not going to have much fun as a data scientist. Now, at the same time, it's very unlikely that you're going to be handwriting the code. For example, one of the tasks that we perform as a data scientist is to apply transformation to matrices when applying the existing models to a particular data set. Now, it's unlikely that you'll be doing that because we have lots of APIs and lots of frameworks. You just call the functions and you apply them on the data sets, and you build the models, and you fine-tune the parameters. So again, understanding the principle will be important, but there may be other roles where you can survive with a little knowledge of mathematics, such as data engineering and data architects. Even if you want to do some data analysis, if you're good at statistics, you can still survive as a data analyst. But if you want to go into machine learning side of things and data science or data science things, you will need definitely a good knowledge of calculus, linear algebra, and statistics. Over to you, Atif. Sorry, I took a little more time than I wanted to.
Thank you. Okay, so I think, like, first of all, of course, if you want to be perhaps in most of the scientific avenues, if you want to be at the top of the game anywhere, you can't exclude maths. That's one thing, right? So even if you're an artist, you can't exclude maths. The reason is, when you are drawing a picture, there are proportions. There are, like, you need to know, like, which proportions would work together for you to paint something, design something. So maths, is there everywhere almost. Now, when it comes to, I'm not good in maths, but you are good enough to graduate from undergraduate school, right? So even though you are not good at maths, you have done maths. So saying that I'm not good in maths, it's about a subjective thing. Where do you want to see yourself? Like, how good or bad you think you are in maths, it depends upon that. The thing about data scientists, and I'll contrast that with programmers, right? So programmers are the ones who develop an idea that is in their head, and their ultimate purpose is the software should be bug-free. And that's it. If it's running, it's bug-free. For example, if it's meant to control a remote control car, then it's well programmed, right? But when it comes to data scientist role is not a programmer role. It's about telling what data is about to tell you. So you are the one who is creating a story out of the data. For example, I see people are tweeting about Trump in a certain way. Okay, then can I predict whether Trump will win, or whether what should Trump change to maximize his chances of winning, or perhaps what the other candidate who's competing against him should do or should not do to compete against him better. When this is happening, these questions are not mathematical questions. So you have to come up with these questions, and these questions are more coming from social sciences. When you are trying to answer that, there are mathematical models that answer those questions. So there is a room whether you want to create a new mathematical model or you want to reuse another mathematical model. And if you are good in using another mathematical model, then of course you can survive as a data scientist without not knowing much detailed maths. When I talk about detailed maths, it means, well, for example, you can't propose a new machine learning algorithm, right? So, but you can utilize the machine learning algorithm. For example, like I'm not good with maths. Can I use MacBook? Of course you can. But can I develop something for the MacBook? That's a different story, right? So likewise, if you can utilize, if you have the clear head that you can think about the data, create a story from there, and if you are good enough to understand, basic level of maths or undergraduate level of maths that you have done in your courses, that should be enough for you to get a standing in data science. But for example, if you want to say, I want to be the best data scientist in the world, then of course, if you want to achieve for that height, for any scenario whatsoever, then you have to detail that. But if you're a little bit afraid of the maths and you want to take a start over here in data science, you can. That's my take. Another thing is, if you're coming to do data analysis, for example, like if I can analyze the spreadsheet or Excel data and generate certain stories out of the stock price and all these kind of things in a business setting, you wouldn't even realize what you have done is statistics, right? So if you ask the person, can you solve me a question of statistics given certain probability problems? That person might say, no, I'm good in using a tool to achieve the target that I'm supposed to achieve. If you have the similar mindset, you can survive in data science. But of course, at certain point, when you detail out somewhere, you will develop further skills along the way. You don't need to be a champion in maths when it's about data science, but of course you should be open. That's what it is. Okay, so there.
Thanks so much. So next I'll go to Nawaz. Like I can see a lot of like interaction going on, and I'm very happy that like loads of audience is now sending me the questions, especially in the different career paths section. So Nawaz, can I ask you? So I just have got a question from an audience that specifically in the software like engineering side or development side, if you can briefly give the names of the current roles which are available in the market and which are like where where most of the jobs are in the software dev side. Nawaz.
Yeah, thank you very much, Ahmed bhai. I'm just going to go back to, we are using a 3-tier or 5-tier architecture in any application development. So once we have a data is cleansed, it's ready to be used. So we need to develop some application. We need to retrieve that data. We need to display that data. We need to ask some sort of the instructions from the user so we can communicate and we can update that data. So there are 3 tiers. I'm just talking very, very high level. So we have a database. We have a mid-tier, where we are going to maybe clean that data, or say we have 100 records and the user needs only 10 fields. So I'm going to give back only 10 fields. Or I might have a loads of business rules to prepare a data set for the UI, for the user to view it. So you guys have covered a very, very, very briefly in data side or databases side. Let me just talk a little bit in the mid-tier side. So in mid-tier, this is a widely used area. Every application, wherever you are going to play with the data, there is somewhere is a mid-tier scripts, a coding required. So let's take an example of any mobile application or any healthcare application or any financial industry application, any application where you put data, even on Facebook. So the languages, as I discussed previously, is we are using a Java a lot. We need to maintain the transaction. We need to make sure the autonomy of the data is maintained. Is not we are going to directly save into the Excel sheet. So we need some sort of the engine who can send data and save that data. So I will say that in that side, if someone is looking for a career path in IT industry, either he should be expert at least three things. He should know how to save the data, how to retrieve the data, and what are the databases, and how I'm going to display that. And if someone is really very good in these three things, he can add the fourth option, which is how you're going to validate, which is a full stack development side I'm just talking. So full stack developer is a one person, is a one man show. He is going to take that requirement, bang on the code, write down the database layer, write down the mid tier, and write down some sort of the automation test cases. And he is going to say, look, these are the 100 test cases I write down based on your requirement, and they are working. You can take that. So these guys are full stack developers, or anyone who has a knowledge of these three layers is a winner in IT industry. But if someone is saying, oh, no, no, I'm fine with the mid-tier. Yes, there are loads of jobs only for mid-tier developers, where a separate set of people are saying, I put that data in the database. A mid-tier developer, he might be using some sort of, say, Express.js, might be using a .NET, might be using some C Sharp, might be using a PHP to just write down some sort of the services and retrieve data and give back. I just want to iterate one thing. Our brother, Dr. Farah Mirza, Allah may bless on him, Janatul Fardos, he was what? Head of API development. So API development is a separate department, it's a mid-tier department, which is just making sure we are preparing data. If anyone needs that data for their reporting, for their UI, for their any analysis, we are going to write down that API. So we have in every big organization, a mid-tier developers are in highly demand. So if I will give the ratio of any team, so we might have like a team of 5 developers, maybe 1 or 2 is a UI developer, a 2 to 3 maybe mid-tier developer, and 1 QA.
All right,
Because
thanks.
all the business rules are going to reside in the mid-tier side.
Thanks so much. So we have got like around 12 minutes left,
Yeah.
and I'm receiving loads of questions. Especially there are top 5 or 6 questions that I just have received from the live audience. So another question, I'm gonna now go to Zishan. If Zishan, so the question is, there are so many emerging fields like AI. So the question is, there are so many emerging fields like AI, IoT, energy sector. Which one should I focus in my earlier career years, Zishan?
Right. Okay. So you mentioned AI, IoT. So these two, and let me add machine learning as well. So these are all applied in almost all sectors. Earlier, I talked about predictive modeling and big data. The AI, ML, are the bread and butter for predictive modeling. In order for one to start the career, it depends the level of interest the person has. So if you like automation plus hardware, then probably IoT is the thing for you. If you can find the patterns and are good in statistics and mathematics and in programming, then you should focus your career as a data science engineer to develop the models. In terms of AI and ML, big giants like Google, Amazon are investing in AI. The AI ML experts can apply their knowledge in various sectors. For example, this IoT is very hot these days. one of the important aspects that many people just overlook is the information security. So as the data grows day by day and everything is connected from smartphones to smart homes, it is critical that the data is encrypted, secure, and access controls are monitored. Hence, it is vital role where one can build their careers, because the loss and breach of data for a company means financial penalties as per GDPR regulation. But the company also loses their trust. They say the reputation comes on the back of a tortoise and leaves on the back of a galloping horse.
All right, thanks so much.
I hope I answered that question.
So, with the time limits, I'm gonna go quickly to the next question. Can I ask Tokir? Yeah. So this question which is asked is about the automation. I'm gonna go to Tokir. Is automation a full career path? Is automation a full career path, Tokir?
Yeah, sure. So yes, it is. I have been it's been my full-time career for the last 15 or more years. What I could say, it is technical area to be in. It is challenging. It is more about breaking things, finding issues in the development, in the process. As I said, before the end user find it, because somebody will find it at some point. So our job is to find those issues before somebody else does. And it's nowadays, because automation or QA has been enhanced and changed a lot, it is very much relying on the automation, which wasn't the case probably a few years ago. Release management has changed, so as our automation, we are relying so much on the automation nowadays. As far as the career, you could be an automation or QA engineer. Then you progress into, let's say, a senior QA engineer or automation. Then you move into principal. Then you can be a lead or something, and an automation lead where monitoring a team of them. You can progress up to QA manager, and there are head of QA as well, in many companies. So depending, how much you want to stay in QA, this is the career that you can move into. Along the sides, I've seen people moving sometimes across. So people kind of, because it is part of the development phase, people sometimes move from QA into product management or project management, those kind of areas as well. Sometimes Scrum Master as well. So there are some hierarchy, going deep into QA, but there are sometimes you can go across in different areas.
Thanks so much, Tokir. I hope these details gonna help our live audience. I got another question from our audience. His name is John. He says that my name is John and I'm in the final year of my college. And so the question is that what is like day-to-day operations for the data analyst? So what is it like for a day-to-day operations for the data analyst? Maybe I can go to Mustafa if you want to answer on that.
Thank you. So basically, we already discussed some of the major part of what the data analysts do. So the data analyst is basically collecting the data or the set of the data from the very large databases or from the data, and then he create this infrastructure on top of it. And from there, he just creates some of the reports. From the reports, or they just analyze the data and create some patterns, like how the data is acting at the moment, or just comparing the data with the previous years or someone's, and just create some trends of that one. So in that case, if you see the data analyst, he can do basically 4 sort of type of analysis in his type. So one is the descriptive analysis, which is what happened to the data. So if we have some sort of information, so we see what actually happens to the data, if there is some trend is going up and down, so he just try to get what happened to the data. The second part, which is he can create some of the analysis, is just to how to diagnose the data. So why the data is, what happened to the data, and why this thing, the trend is changed, or what happened and what will be going in that say. So that is the diagnostic part of it. Then the third, which is already discussed, is the predictive analysis. So in the predictive analysis from all the data trends he get, so he just predict and he say like what likely to be happen in near future or in future. So which is sort of a predictive modeling as well involved in that case. But the fourth part is how to, from that predictive modeling, what action should be taken to that what you are predicting should be work in that case. So he has to do like 4 different types of analysis in his duty to get all this information gathered and make the decision on that, on the top of that.
Lovely. Thanks so much, Mustafa. We just got a question. Which field a new IT person should choose? I believe we already have covered it, so I'm going to skip now on this question. So whoever has asked, so we already have covered this question. Another question that live audience has just asked. His name is Bilal, and he's doing MSc in Cork, and he's more interested on the PhD side. So maybe I'll go, to Akil. So Bilal is asking that what is like day-to-day job for a PhD graduate, and especially after the PhD, if he's doing a postdoc researchers or senior like researchers in the IT industry, how that is different from pure industrial jobs without PhDs. Dr. Akil, if you want to shed some light.
Yeah, sure. So PhD graduates, or let's say post-PhD researchers, they are actually the research scientists. And research scientists work in almost every area of science that you can imagine. The main duty or responsibility of a researcher is to advance knowledge, and that's the key role when you take this job. Now, because I work in academia and I've been working in academia, I don't have any experience in the industry. I can talk from academic point of view and from academic side of the things. How is it in academia? There are you can compare it with few factors. Why I personally, with my experience, why I chose to stay in academia. There are a couple of key points: flexibility and work independence. That's one thing that you get offered in academia. So flexibility is usually an advantage when you compare working in academia as a research scientist with those who work in industry. Well, in industry, there are so many industries now. They have opened R&D cells, and you can go there and work as research scientist as well. But the flexibility and work independence may not be the points or the key areas, the key advantages that you will be offered in the industry. Then the second thing that I would say, I'm in academia, I don't want to go in industry, is perhaps maybe if I get something innovated, if I come across some invention, or let's say if I do some novel work, who will get the credit? Well, if you're employed at a junior level in industry, you will rarely get external credit for your work. But in academia, you're credited for whatever amount of work you do. From industry point of view, I would perhaps invite somebody else who has an industry experience in the same context to shed some light on this and see how it's different. But I see these 2 points, main points, that influence me to stay in academia and other people as well.
No, that's good, because like on the like on the industry side, we already have covered a lot in this session, and you have now well covered on the academia side. I really appreciate so Keith. I just have got a question. Actually, our our helper who is supporting us, Ikram Niazi, has got a question on the Facebook, and he has pinged me here. It's an interesting question: how emerging technologies can affect the creative economies in developing countries. I'm surprised, that our audience is asking us, like deep level of questions. Maybe I can go to, to Atif, if you wanna answer that, Atif.
Sure. Okay. So, I mean, I want to keep it short because I know we are very tight on time. So, just two things: the way election campaigns have worked in US, the way Brexit has happened. We can see the role of social media in this. So this shows the emerging technologies have changed the way we function. If we see in terms of disaster management, we know that the technologies such as censored Wi-Fi signals and all these kind of things, when disaster happens, those are the ones that will work, because other infrastructure would be eliminated from the ground, most likely. So if we say the emerging technologies, do they affect creative economies? Yes, they do, and that's the driving factor. If you see why China is up in the race, because they're investing heavily on technologies, right? And that is what is making them unique. And likewise, if you see anybody, I mean, even if you're in Ireland, if you have a creative idea, if you're showing the way some disruption can happen, some new ways of doing the old stuff, but bringing efficiency to that, speed into that, or perhaps improving the quality, then yes, this is what we want to achieve. Pandemic, COVID happened. We saw that virtual platforms took over. That's a different technology. That's a new technology that has created, businesses to think in a different way, helping them out as well. One of the good examples here is, a lot of the industry found shutting down their actual business units saves them renting cost, so they can hire more employees to work from home. They might multiply instead of downsizing, they have actually hired more people. So that they're not renting the place, everybody's working from their home. So it saves commuting as well. So things are changing, and they will continue to change. And if this was true like 100 years ago, this is still true, and in the future it will be true. So emerging technologies, yes, there is a risk, but there is always a demand for that. And the growth comes with risk, of course, but we control the risk somehow. So there is definitely a potential in this, and this will stay valid for as long as I can think of.
Thanks so much, Atif. So based on the time, I'm going to go to a last question, which is asked by Raj and Mike, from Dublin, and it's very similar question. So I'm going to formulate it into my own words. So maybe I'll go to Mustafa and Zishan on that. So what is the difference of big data pipeline development versus big data platform development? What is the difference of big data pipeline development versus big data platform development? Maybe I'll start with Mustafa.
Thank you. So the big data pipeline development, basically the big data pipeline development is similar to what is the ETL, like the extract, load, and transform and load. So the pipeline development is just from the transfer of data from one system to another. So that is the main concept of what is the pipeline development. In case of the big data development, is a bigger job, which is to how to analyze or how to get all the data from the different sources and load it into a bigger environment, so that the data can be used in the bigger applications, or the data which we have to use in the larger analysis of that data. So the first part is the pipeline tool is just the ETLs, which is extract from different sources from one source to another, and the big data development is the develop the whole system which could get the data into the big data and then extract and then go to them for the use for the analysis and for the other APIs and whatever we have to use that.
Okay. So I'll go to Zishan if you want to add something here, Zishan.
Yeah, thanks. So basically, very quickly, a data pipeline is a system that captures, organizes, and routes the data so that it can be used to gain the insights. The raw data contains too many data points that may not be relevant. The data pipeline architecture organizes those data events to make reporting, analysis, and using that data easier. When we talk about the big data platforms, so I can give you a few examples. For example, Microsoft Azure, HD Insight, Tableau, which is a very good data platform, big data platform that one can use to do the visualization. MapR, Qualtrics, Oracle, so these are all the examples of the big data platform that uses the data and analyzes it to solve the complex problems and can provide the visualization aspects to the data.
No, thanks so much. So with this one, based on the time, we have covered a lot of questions, guys, and I'm sorry. So there are many other questions that I've received, from Usman, Suleiman, Mariam, Adit, yeah, so Nail and Nasir. So we're gonna take them offline. We don't have time right now, but thanks very much for taking out time to ask the questions. With this one, I hope that this was, a useful session for you guys, and the audience who has attended us. I hope you will get some information, and it will help you to take the decisions in life if you want to if you want to come into IT industry, and what are the different roles in the IT industry, and what are the job specs, and what are the hot trending specs in terms of the tech stacks. So with this, I just want to wind up by saying that if you have any feedback, please give us the feedback. We have so we have the WhatsApp group, we have a Facebook channel, so please give us the feedback to improve. If you have some idea for next if you have an idea, or if you have a question or something that you specifically want to ask, you can tell us and join us for the next fire chat session, which hopefully will gonna come in the next month or so. With this one, I want to thank all of the panelists who have spent the time and taken out the all the time, and all the best. Thanks so much, guys.
Thank you very much, guys. Bye.
Thank you very much.
Thank you.
Bye.
Thank you.
Thank you.
Bye.